Hi everyone, welcome back. We are continuing our discussion about activation functions. So, if you are interested in knowing what is an activation function or the basis of it, the fundamentals of it, please watch the previous video on ReLU activation. Today's video is a continuation and we are going to discuss sigmoid activation functions, its usage, the formula, which is displayed. Okay, it is denoted by the sigma sign, which is like this. And the formula is sigma of x is equal to 1 by 1 plus exponential function of x. That is e raised to the power of minus x. E raised to the power of minus x. So, like how the ReLU activation function, it had a simple formula, just max of 0 or x. That was the simple formula. Here it is 1 by 1 plus x or e raised to the power of minus x. Okay, where x is the input. Okay. What is the properties? A very important property of the sigmoid activation function is that its output is always between 0 and 1. Its output will always lie between those two values. Okay. As x approaches negative infinity, it approaches 0. As it approaches positive infinity, it approaches 1. And when you plot a graph with different values of x, you would see that the sigmoid function, the graph has an S shape. The shape of the graph is the letter S. So it will go infinity, infinity, it will go to 0 and it will go to 1. So the value is always between 0 and 1. It is the S shaped. It is also called as the sigmoidal curve. Sigmoid function is also monotonic, which means it is increasing. As x increases, the output, the value of the function, this also increases. It never decreases. So it's corresponding to the value of x. It's also derivative. The derivative of the sigmoid function is very easy to calculate. And this is how you compute the derivative. So derivative of the sigmoid function is the sigmoid function itself multiplied by 1 minus the value. Okay, so it's very easy. Now, it is this property of the sigmoid function that is very useful in backpropagation. So in neural networks, just let me talk briefly about what is backpropagation. So when you first start training the model, as you saw in the previous lecture, all the weights and biases are randomly assigned. So obviously in the first training run, the output, what you get, is nowhere close to what it should be. So what happens is then the neuron sends signal back, and what happens is the previous layers adjust their weights and then again run the model and again compare the output. Is it what it is supposed to be? Oh, not yet. Let's go back again and change all the weights and biases again. Because as you change the weights and biases, what happens is the sum changes. Because what we do, we multiply the weight by the input plus the bias. That's the formula. So as the weight and the bias change, the output changes. And it goes on and on. You have to go on training the model until the output comes to what you expect. And this property is very useful in that backward propagation step. Sigmoid function is also very helpful when you have non-linear data. And one another property is because the value is always between 0 and 1, The sigmoid function is used, generally used, the activation function, when you have a classification problem, which means you need to classify the data whether it belongs to class A or class B. That simple classification. Okay, say let's for example in breast cancer detection, either the tumor is malignant or it is benign. So classification problem. But in most real life situation, you would see that you cannot clearly distinguish the data simply by this one straight line. Like all the data points are here and the remaining data points belong here. It's not possible in real life, actual real data, because the features are so complex. So that's how this is a non-linear classification, that one data point belongs here, here, and that is where the sigmoid function comes in handy. Okay, let's see a Python example of the sigmoid function. If you had to implement yourself, here it is, very simple. 1 by 1 upon, we use numpy, okay, e raised to minus x. This is simple, just like the previous one. We define a layer with certain inputs, weights, biases, randomly initialize the inputs, number of neurons, shape. This is how what is going on in the background. But when you are actually writing a machine learning code or a classification code, you use one of the libraries. And if you're, this is just an example of how you would use it. If you're using TensorFlow, it has here, see, you simply give the activation function equal to sigmoid, and the layer Keras knows how to use it. Okay, so this is how simple it is to use it, but you have to know what goes on behind the scene, what's the formula, so that if you run into any issues or if you have to do back propagation, where do you look at? How do you adjust the weights? Okay, all right, that was it. Thank you all. See you all again in next recording with some more AI concepts. Feel free to like, subscribe, comment. It's your choice. All right. Thank you all. See you all next time. Bye.